Hello, sixth grade. Today is going to be our last lesson in our solids, liquids, and gases unit. So today we're going to talk about gas behavior. First, we're going to read about Jacques Charles. So this is the biography part of the My Planet Diary. So I'm going to read it to you. French scientist Jacques Charles is best known for his work on gases, but he also made contributions to the sport of ballooning. On August 27, 1783, Charles released the first hydrogen-filled balloon, which was about 4 meters in diameter. This balloon, which did not carry any people, rose to a height of 3,000 feet. Charles also improved the design of hot air balloons. He added a valve line that allowed the pilot to release gas from the balloon. He also added a wicker basket that attached to the balloon with ropes. Charles was elected to the French Academy of Sciences in 1785. So we talked about hot air balloons a little bit in the first lesson. So the question that goes with this short little story is, what sport or hobby inspires you to want to know more about science and why? So I want you to think about that, and if you want to send me a message on Edmodo with your answer, that would be awesome. I will definitely look at those. The sport or hobby that inspires me to want to know more is actually disc golf. So if you haven't heard of disc golf, it's similar to golf, but you're using a frisbee. And so the big thing about that the big thing about that inspires me to want to know more about science is there's just so much to like your throw. If you think about a golf swing or a baseball swing or even like a basketball shot, there's so much science just packed into your shot. It's like there's so much to look at when you do that. So that one's mine. If you want to send me yours on Edmodo, go right ahead. Okay, so our key questions for today are going to be, how are pressure and temperature of a gas related? How are volume and temperature of a gas related? And how are pressure and volume of a gas related? Okay, so first of all, if we think about a gas in a closed container, when you heat it, the particles will move faster, colliding with the walls of the container with a greater force. This results in greater pressure. So we look at our answer to that first key question. When the temperature of a gas at constant volume, meaning the volume is not changing, is increased, so we have a hotter temperature, the pressure of the gas increases. And then on the opposite end, if the temperature is decreased or it's lower, colder, the pressure also decreases. So we talked about up here, if you heat the gas, its particles move faster, meaning there's more pressure within the container, but if you're cooling the gas, then the particles will move slower, and then they're colliding with less force, which is less pressure. So let's look at this. I'm going to move my bubble probably right here so you can still see everything. So we have a couple steps here. So we have a balloon. It's filled with gas. It's at room temperature, which is 20 degrees Celsius. The balloon is then lowered into liquid nitrogen, which is negative 196 degrees Celsius. That's really, really cold. Okay, so then in the liquid nitrogen, the balloon shrinks as the gas volume decreases. So because of the temperature being so cold, the balloon is shrinking in that liquid nitrogen. But then when the balloon is removed, the gas warms again, so it gets hotter, and then the balloon expands. So then finally the balloon is again at room temperature, and this looks the same as it did in the first picture. So the air inside the balloon cools, the volume decreases. When the air warms up again, the volume increases. So Charles's law. When the temperature of a gas at constant pressure, so the pressure isn't changing, is increased, so it gets hotter, its volume increases. When the temperature of a gas at constant pressure is decreased, its volume decreases. So in that last picture, if we go back, the liquid nitrogen was cooling the temperature of the balloon, which was then decreasing its volume. But then once it warmed back up to room temperature, the balloon was back at its original volume. So then that's what it says here. So Charles's law is the answer to our second key question. When the temperature of a gas at constant pressure is increased, its volume increases. When the temperature of a gas at constant pressure is decreased, its volume decreases. Okay, so then let's talk about something a little different. So we're going to talk about the definition of directly proportional. So what does that mean? The relationship between two variables whose graph is a straight line passing through the point 0, 0. So right here in our little graph from Charles's law, we can see temperature in either Celsius degrees or kelvins. That's another term that science uses. And then the volume in milliliters. So we have our temperature on the bottom in kelvins and our volume on the side in milliliters. So we're starting at 0, 0, and then it's just plotting all of these points. So we go up to 50 milliliters right here. We see the 273 kelvins, then we go to 54 and all the way up. So you can see it's a straight line. It goes through 0, 0. So that's what directly proportional means, is any of those two variables are going to be proportional to each other. So the graph shows the volume of a gas. It's directly proportional to its Kelvin temperature at constant pressure. Now we have Boyles Law. Let's try it right there. When the pressure of a gas at constant temperature is increased, so remember temperature isn't changing now, the volume of the gas decreases. So when pressure is increased, the volume decreases. And then when the pressure is decreased, the volume increases. So again, that's the answer to our last key question. When the pressure of a gas at constant temperature is increased, the volume of the gas decreases. When the pressure is decreased, the volume increases. So then this is going to create an inversely proportional graph. So this is when the product of two variables is constant. So the product's never going to change because it's increase and decrease. So they're at two opposite ends. So the product will not change regardless of the two variables taken from the chart or multiplied. So let's say that I'm just throwing out numbers. The pressure of the gas is 5 and the volume is 2. Okay, so if we multiply those together, we're going to get 10. So then let's take another one. If the pressure is 10 and the volume is 1, we multiply those together and we get 10. So the product is never going to change in that situation. So let's go over our vocabulary again real quick. So we had Charles's law. When the temperature of a gas at constant pressure is increased, its volume increases. When the temperature of a gas at constant pressure is decreased, its volume decreases. Directly proportional meant that the relationship between the two variables whose graph is a straight line passing through the point. So it created that straight line going through 0, 0. Boyles' law states when the pressure of a gas at constant temperature is increased, the volume of the gas decreases. When the pressure is decreased, the volume increases. And then inversely proportional meant that the product of the two variables, when you multiply them together, is always going to be the same, no matter which two variables you take. So that's all for our lesson 3 today. You're going to have an Edmodo quiz. It will not serve as a quiz, but rather just like an assignment. So you're going to do that on Edmodo. If you need to use the PowerPoint or the video, you definitely can, or notes if you took them. Thursday, we're going to do a little review before you take your quiz on this chapter. If you have any questions, as always, let me know.